I wanted to do one more video to help you with orbits. And in this video, I actually put in the mass of the sun, the period of whatever planet I'm interested in this case it happens to be Jupiter. Then this is a constant, capital G, 6.67 times 10 to the minus 11th. Then I calculate the distance of the planet to the sun cubed, take the cube root of that, and then convert it to kilometers. How do I do this step? This is the key step. This is where I use the equation for the gravitational equation for orbits that I talked about in the last few lectures. What I do is I take g, multiply it times the mass of the sun, that's g times m, divide it by 4 pi squared, which is this term here, and then multiply the whole thing by the period of the sun, the period of the orbit in seconds, which this is days here, I have to convert days to seconds, and then I square that number. That's what this is here. That result is given in this location right here. There we go. The result is given there. Divide it by 1,000. Take the cube root of it, divide by 1,000. That gives me the distance of the planet to the sun in kilometers. So let me show you that this works. If I go into the internet and look for the period of Jupiter, it'll tell me how long it takes Jupiter to go around the sun, and this is the number I put in, 4,332 days. And let's see if I get the right orbital distance. It tells me that the orbital this site tells me it's about 483 million miles. I calculated, oh, that's in miles. I need it in kilometers. There's the units issue. I'll go for distance of Jupiter from sun in kilometers. There we go. About 779 million kilometers. I calculated 778 million kilometers. Keep in mind, Jupiter's distance, or any distance, any planet's distance from the sun, varies. It doesn't orbit in a perfect circle. So this number is not a perfect number, but it's quite close to the average value. For comparative purposes, I'm going to pick one more planet. I'll pick Mercury. So let's figure out whether I could do this for Mercury. So I'll find the period of Mercury around the sun. And it looks like Mercury takes about 87.97 days to get around the sun. So Mercury only takes about 3 months to get around the sun once. That's why it moves very quickly. That's why it's rather difficult to see, even though it's not as far as some of the other planets. So I'll put 87.97 days in here. So where I had 4,000 something days, I'm going to put 87.97, and as soon as I press return, it'll calculate the number of seconds, which is what I have here. I didn't label it, but that's the number of seconds for the orbit, and then it'll calculate all these other values here for me, except for this one. That's about 57.9 million. I'll say 58 million. And let's see what the internet says. For the distance of Mercury from the sun. It should be one of the first things. Whoops. goes between 69 million and 48 million, it looks like. The average is about 58 million kilometers. What did I calculate? Oh, I called it miles. It should be kilometers. Sorry about that. I calculated the same thing that the internet reports for the average value. You could do this for any planet. All I'm doing is applying the equation for orbits here. Hope this helps you in your calculations. Take care.